Hello friends, in today's question, in an experiment to measure the speed of sound by a resonating air column, a tuning fork of frequency 500 Hz is used. The length of the air column is varied by changing the level of water in the resonance tube. Two successive resonances are heard at air columns of length 50.7 cm and 83.9 cm. Which of the following statements are true? So in this case, we have to find out, or rather we can check whether all these four options are correct or not. So we are given that there are two resonance lengths 50.7 centimeter and 83.9 centimeter, and the frequency of tuning fork is given as 500 Hz. So we can write that frequency of tuning fork is 500 Hz, and we have two successive resonances, so we can write it as successive resonance lengths First, let us call that L1, which is our 50.7 centimeters. This is our first resonance, and we can write second one as L2, which is our 83.9 centimeters, and this is our second resonance. So based on these two, L1 and L2, let's calculate the wavelength. So wavelength, which we are calling it as lambda. So we have two lengths. So let us draw in an approximate figure. So this is our L2, the entire length, let us suppose. This is L2 and it is our 83.9, and second one will be our L1, that is our 50.7 centimeter, and the difference between these two will be equal to lambda by 2. So we are going to use the same condition that the two resonance lengths correspond to consecutive odd harmonics. So therefore we can say that our lambda by 2 will be equal to L1 minus L2, which is 83.9 minus 50.7. So this gives us lambda by 2 will be equal to 33.2 centimeters, or we can say our lambda is equal to 66.4 centimeters. So option number C is true. The wavelength of the sound wave is 66.4 centimeters. You can say option A is true. Sorry, not option A, option C is true. Now let us find out what will be the harmonics that will be associated with L1 and L2, because we only know one thing, that these are the successive resonance lengths. So we are going to find out the harmonics associated with L1 and L2. Determining harmonics for L1 and L2. So let us assume that it is a closed air column. So you can say for closed air column, the harmonic number n for the resonance length is related by the harmonic number n we can write this as ln will be equal to n lambda by 4 plus e, where e is our end correction and n is the odd numbers. Okay. So we have n as 1, 3, 5 and so on, and e is our end correction. So the first harmonic, or we can say harmonic for L1, and the length of L1 is given as 50.7 centimeter. So we can say harmonic for L1, which is our 50.7 centimeters, and it is basically hit and trial method. We are going to start by submitting the value of n as 1, then 3, and then 5, and so on. Okay. And we can say that our L1 will be coming approximately equal to 3 divided by lambda by 4. So this becomes as 3 into 66.4 divided by 4, and which is about 49.8 centimeters. So this is the closest, or we can say closest length to the L1. So we can say this is the calculated value which is very close to L1, which is about 50.7 centimeters. Therefore, we can say that L1 corresponds to third harmonic. Therefore, L1 corresponds to third harmonic. And similarly, we are going to do for L2 also. So we can say harmonic for L2. And value of L2 is our 83.9 centimeters. So both L1 and L2 are the consecutive resonances. So the next value of n, which is consecutive to 3, is 5. So therefore we can say that our L2 will be approximately 5 multiplied by lambda by 4, and which we can write 5 multiplied by 66.4, which comes as 83.0 centimeters, and this length is close to L2. You can say this calculated length is close to L2, which is our 83.9 centimeters. So therefore we can say that L2 corresponds to fifth harmonic. L2 corresponds to fifth harmonic. Now we can calculate the end correction. And we can calculate end correction for using third harmonic as well as for fifth harmonic, and the value will be same for both. So let us try it for third harmonic. For L1, which is our 3 lambda by 4 plus E, and from here we can say our E will be equal to L1 minus 3 lambda by 4. So end correction E, we know that our L1 is given as 50.7 minus 3 lambda by 4 is our 49.8, which comes close to 0.9 centimeters. And similarly, we can calculate for L2 also. So you can say for L2, this will be equal to 5 lambda by 4 plus E, or we can say E will be equal to L2 minus 5 lambda by 4, and this gives us that our E value of L2 is our 83.9 minus this will be 83.0, giving us 0.9 centimeters. So finally, in both the cases, we got that the end correction is our 0.9 centimeters. So option B is also correct option. So we can say option B is correct. And let us calculate now speed. So we can say speed of sound, which is given as V, and V will be equal to F into lambda. F is our 500 and lambda is our 66.4 centimeters or 0.664 meters. So this gives us that velocity of the sound will be coming close to as 332 meters per seconds. So the option number A is also correct. Option A is also correct. And finally, we are going to find out the length for fundamental harmonic. Length of fundamental harmonic. And for fundamental harmonic, value of n is equal to 1. So we can write that our length for fundamental harmonic will be equal to lambda by 4 plus E, and lambda is our 66.4, and end correction we found at 0.9, and this comes close to as 17.5 centimeters. and the options that is given regarding the corresponding to fundamental harmonic is given as 50.7. Obviously that is not for the fundamental harmonic, but that is length for the third harmonic. So this option is wrong option. So D is incorrect. Option D is incorrect. So the correct options are A, B and C. A, B and C are correct. So this completes the question. Thank you.